Hi, hello, assalamualaikum. Welcome again to chapter 3, which is question 3-64 from Unit's channel Thermodynamics book. So we just continue here, which is piston cylinder device initially contains steam at 3.5 megapascal, superheated by 5 degrees Celsius. Now steam loses heat to the surroundings and the piston moves down, hitting a set of stops, at which point the cylinder contains saturated liquid water. The cooling continues until the cylinder contains water at 200 degrees Celsius. It's actually have a various or a step of distance work. So determine initial temperature and enthalpy change per unit mass of the steam by the time the piston first hit the stops, and the final pressure and the quality. So here they want delta H, T initial, final pressure, P final, and X. So we start first with A, which is Tsat Tsat at 3.5 megapascal is 242.56, which is the initial is 242.56. We can see at table A5, which is VF and HF here. Table A5, because we can say that here it will be before it will be superheated, it must be saturated steam. So here I got 242.56. It's actually stated in table A5, which is at P 3.5 megapascal, and you can see the top one. Yeah, you get 242.56, and you can get the VF and HF. And then the question starts superheated by 5 degrees Celsius. So the T set plus with 5 degrees Celsius to get the T initial actually. So the T initial is actually T set plus 5. So we get 247.56 degrees Celsius. So B, enthalpy change. Enthalpy change is actually, we can see here, P1 equals to P2 MPa, which is a constant pressure, and the pressure inside the cylinder remain constant, and it will be your P2 equals to P1. And then you can see at table A6, which is table superheated water, you can find 242.56, and you can find 250.250 for T. And then you just need to find for enthalpy for temperature 247.56. So by using interpolation, you get the H1, which is 2820.85 kg per kg. Okay, and then next, the question asks the enthalpy change, so we need to find delta H. So here you can find P2, since P1 equals to P2, you can find here H2 equals to HF at 3.5 megapascal is 1047.9, which is here you can find at table A5, which is table saturated. So you can get the answer, which is negative 1772.95 kilojoule per kg. Okay, this is your answer for B. Your answer for C, after the piston hits the stop, the whole cooling process occurs at V constant. So we know that if V constant, it will lead to V3 equals to V2. So V3 equals to V2 is actually VF at 3.5 megapascal, and this is your answer, 0.001235 meter cube per kg. And how you can find this? You can find at table A4. Table A4 at T3 200 degrees Celsius, and you can find this and this, and actually you can get the answer here, which is p set is 1554.9. Actually it is just like straightforward answer. If you open your table A4, you can find straight away beside the 200 degrees Celsius, which is Y554.9 kilopascal. So by using this formula to find the X, which is the quality, and you can find the answer X is it, which is 0.006, 0.0006. Yeah, I think that's all, because for me the question itself is might be complicated, but you need to understand the process of the piston first, which is from saturated to superheated, and then they cool with the cooling process continues. So it will have T1, T2, T3, V1, V2, V3. It will have three processes. So I think that's all for this question. Thank you.